This is an SPSS tutorial showing linear regression and the analysis. The scenario here is that researchers wondered whether mass of the bullfrogs was related to length. They measured length and mass of 11 bullfrogs in this study. So when you open SPSS, you'll be faced with this window here, and you can either select a previous file, or in this case I'm just going to close the file. And there are two different sheets. Currently, you can see the different tabs down here. We're in the data view sheet. It looks just like a spreadsheet in Google Sheets or in Excel. This is where all of the data would appear. There's also this variable view tab, and this is where you would set up the variables themselves, which would be the column headings for each of the columns in the data sheet. So the variable view, you'd set up using that tab. I have all of my data already in an Excel spreadsheet, so I'm just going to import that. So I'll go up to File, Import Data, select Excel. You can also select if you have your data in a CSV form or any of the other forms. Mine's in Excel, so I'll select that. And I'll navigate to my spreadsheet, click on it, and go ahead and click Open. I'll be given a window shown here. And if you have multiple sheets in your workbook, you would select them by clicking here. This is the correct one. I want to have check read variable names from the first row of data because my variable names are in the first row in my sheet, and everything else looks just fine. So I'm going to hit OK. And you'll see that SPSS populates my data sheet with all of the information from my Excel spreadsheet. I do want to double check and make sure that the variables are set up correctly, so I'll go to the variable view and see that, yep, each of these variables are the ones that were the column headings. So I'll take a look at date. Date is set up as a date variable. That's great. I'm going to go over to the measure and make sure that the measure matches the type of variable, so it's a scale or a continuous variable. Length is also numeric, also continuous, and mass is also numeric and continuous. If I wanted to change the type of variable, let's say length, for example, was a categorical variable, I would click here and then select string and hit OK. So if it's text or categorical, and you can see in the measure column that the string variable or the categorical variable now has changed to a nominal type of measure. So categorical, nominal, so they agree. But my data are numeric, so I'm going to go ahead and change that back. And again, I do need to change the measure, the measure back to scale. And everything looks fine, everything's there. Okay, so to run the regression analysis on my length versus mass, I'm going to go ahead and go up to the Analyze menu and go down to regression, and for my purposes I'm going to run a linear regression analysis. So I'll select that, and you'll be faced with this window here. My dependent variable in this case is mass, and so I can go ahead and select mass. I can either drag it over or I can click on it and hit the right hand arrow. And then my independent variable is length, so I'll go ahead and put the length into the independence field. And like I said, you can drag it if you want. Date we're not using, that's not really part of this analysis, so I'm going to leave it in this window. There's a lot of different options over here, so if I click on the statistics field, here I want to include the descriptives, which will give me means and standard deviations. I also want to collect confidence intervals, and everything else looks okay, so I'll hit continue. You can have SPSS do some plots by using this field here. You can have them do normality plots or histogram plots. I'm going to do my plots separately, so I'm going to just go ahead and click on cancel here. You can also have SPSS save information, and it would save it in the actual data sheet, but we're not going to do that. And then there's also options, which everything looks okay there, so I'll cancel out. Style, don't really know what that is, cancel that. And I'm going to go ahead and click OK for the analysis. So SPSS creates an output window, which is a separate file from the data sheet itself. So let me just put these side by side. So it would be like having a Word document and an Excel document. If you go to Window, you can see there are two separate files, the output and the data set. So just when you save one, you have to make sure you save the other as well. So let's go ahead and look at the analysis. Here's my descriptive statistics where it gives me the mean for the mass and the mean for the length along with the corresponding standard deviations. It gives me sample size of 11, and since these are XY coordinates of mass and length, the sample sizes should match. I have a correlations table, which here it shows me a Pearson correlation analysis that mass is highly correlated with length. It's 0.905, so that's really high. And the correlation is significant, as can be seen by this section here, which is the p-values. So I have a p-value that's less than 0.0001, very small p-value. And then I'm going to go down to the model summary table. And here, importantly, is the R-square value, my regression coefficient. So it's 0.82. We'll talk about that in a minute. Here's the ANOVA table, which shows there's a significant regression, as you can see in the SIG column, which would be my p-value. Again, very, very small p-value. Okay, and so now down here on the coefficients table, this gives me information for my regression model. And so the slope for my regression model would be 6.523, and then my y-intercept would be negative 603, or 602.679. So I do have a significant regression, as shown in this ANOVA table. So you could write down the model and make predictions between mass and length. There's that significance showing the regression. Importantly is this R-square value, which is 0.819. And so this indicates that 82 or 81.9% of the relationship between the mass, the bullfrog mass and length, is explained by this linear regression. The rest of the variation, that other 18%, is due entirely to chance.